Electrical Machine 2, code EX501, Unit 1, DC Machine Part 1. In this lecture, we are going to see different types of windings used in DC machine. Majorly, there are two types of winding used in DC machine. One is lap winding and other is wave winding. Other windings that are used in DC machine are field winding, which is not the part of our today's discussion. Lap winding. In simplex lap winding, the coils having two coil sides are connected to the two commutator segments as illustrated. Note that the two coil ends, one from the top coil sides and the other from the bottom coil side, are connected to adjacent commutator segments. The simplex lap winding term refers to the fact that the coil 1 is placed in the slot adjacent to coil 2 and coil 2 is placed in slots adjacent to coil 3 and so on. The lap refers to the fact that the coil 2 laps over coil 1 and coil 3 laps over coil 2 and so on for one parallel path. The lap winding is also known as parallel winding. In DC machines, the coils are mostly full pitched. Wave winding. A simplex wave winding in which the two coil ends of a coil are bent in opposite directions and connected to commutator segments which are approximately two pole pitch, that is approximately equal to 360-degree electrically apart. In wave winding also, each commutator segment has two coil ends connected to it, one from the top coil side and the other from the bottom coil side. In order to understand the various nomenclatures used in understanding the measurements related to lap winding or wave winding. Only the armature coil and commutator bar in the representation shown are utilized. In commutator machines having closed windings, the coil sides for convenience are numbered as illustrated. Note that the top coil sides are numbered odd: 1, 3, 5, 7, etc. And bottom coil sides are numbered even: 2, 4, 6. Front of armature denotes commutator end, and back of armature means the other side of commutator. YB represents back pitch. The distance between the top and bottom coil sides of one coil measured at the back of armature or measured at the other side of the commutator is called back pitch. It may be expressed in terms of teeth, slots, or more conveniently in terms of coil sides. Here in this example, coil side 3, coil side 1 and 6 forms the top and bottom coil sides of coil number 1. And the back pitch is the difference between 6 and 1, that is 6 minus 1 equal to 5. So the back pitch of coil 1 is equal to 5. Front pitch. YF represents the symbol YF represents front pitch. The distance between the two coil sides connected to the same commutator segment is called front pitch. The top coil side of the second coil and the bottom coil side of the first coil connected to the segment 2 are 3 and 6. And the difference of these two coil sides in terms of coil side numbers 6 and 3 is 6 minus 3 equal to 3. So the front pitch of this coil connected in lap winding is 3. Commutator pitch. The distance between the two commutator segments to which the two ends of one coil are joined is called commutator pitch, and the symbol is YC. It is always expressed in terms of commutator segments. For simplex progressive winding, the commutator pitch is always +1. Winding pitch. The distance between the two consecutive and similar top or bottom coil sides as the winding progresses is called the winding pitch. The symbol is YW. It is expressed in terms of coil sides. Winding pitch is equal to the summation of back pitch, the difference of back pitch and front pitch in lap winding. So the winding pitch for the given diagram is YB minus YF, that is 5 minus 3 equal to 2. It should be noted that these calculations can be made if the total number of coils are known and the total number of poles in the machine are known quantities. So from these given quantities, total number of coils and total number of poles, the back pitch can be calculated as twice the number of coils divided by the total number of poles plus or minus a constant which is added or subtracted to make this number an odd number. Also note that the number of poles also defines the total number of brushes and the number of parallel paths that will be formed in lap winding.